Hi, these examples are from this book, which is Single Variable Calculus. If you wanted to get a supplemental resource for your calculus, I highly recommend this book, and you can get the hardcover or paperback or even the text electronic textbook for it. And so let's go for our question, and this question is from this book, and it says biologist has noticed that chirping rate of crickets of a certain species is related to temperature, and the relationship appears to be very nearly linear. A cricket the cricket produces when the temperature is equivalent to 70, then we have the number of chirps, and we're gonna represent it by n is equivalent to 113 chirps per minute. And when the t equivalent to 80, then we have n equivalent to 173. And so if you notice over here, but when the temperature increases, our chirps per minute also increases. So what it wants from us, find the linear equation that models the temperature T as a function. So it wants from us to get basically to get the T as a function for n. So what we want to get is T as a function for n. And also it wants from us slope, and we're gonna name it M. This is our requirement. This is the second requirement. And the third one is it's given us n, and in third requirement it says if n 150, then what is the temperature? It says give me the temperature. So let's go for the solution. I have written everything. It says when the temperature is 70, then n is 113, and when the temperature is 80 and chirps is 173, so we have increase, and it wants from us the t as n function and the slope, and this is the third requirement. So let's go for the solution, and we're gonna start with the first requirement. So this is similar to a situation where we have 2 points and we're gonna need to find an equation. And in this case, our equation is T of n. And in order to get that, we have 2 points. So what we're gonna do when we have 2 points is we're gonna get the slope from these 2 points. And after that, we're gonna use the slope and another one of these points to represent our function. So let's get the slope first, which is slope is equal to m. We're gonna name it m, and we're gonna say t2 minus t1, and in this case t2 is over here, the 8 is t2 minus t1 into minus n1, and what we will get is t2 is 80 minus 70, and n2 is 173 minus 113, and we're gonna get a value 1.6. So this is our slope. And what we're gonna do is we're gonna substitute slope and one of the points that we have, or in this case the temperature and the chirps, to get our T of n, which is our equation. So T of n is what we're looking for, and what we're gonna do is T2 minus T1, and in this case T2 is what we're looking for, and the T1, one of these points, is equal to m n2 minus n1. So basically n2 and T2 is not known for now, because even though we have the T2 over here, but that was different case because we are now using a different point. And so we're gonna take one of these points as a T1. So let's take this point. So what happened? T2 minus 70 is equivalent to our slope 1.6, and N2 is in this case 113, or sorry, that's what we're looking for, and N1 is 113. And after doing, you're gonna end up T2 equals 1.6 N2 plus 51.16, and I think some values over here. So what we're gonna say is Tn, T of n is equal to T2, which equals to N2 plus some values, and this is our function. So we got our first requirement. So let's go for the second one, and just for the second one, it's asked from us. It says what is the slope of the graph? Well, we already found the slope, which was 1 divided by 6, and so we have slope is equal to 1 divided by 6. And what does it mean? It means when temperature increases by 1 degree, then our chirps per minute increases by 6. So this is the rated cost. When we have the temperature increases by 1 degree, then like we have from 1 to 2, then our chirps increases from 6 to 12. Same, if we go from 2 to 3, then we're gonna go from 12 to 18. This is just an example. This is the way it works. This is the increase, and it says the last requirement. So this was the second requirement, and we're gonna go for the third one, which says find me find the crickets, estimate the temperature when the chirping is 150. So basically we already know our function is equal to, this is our main function. Some values over there. So it says if you have the n equivalent to 150, then give me what is the T of n at that value. So we have 150. So this value, so we're gonna end up with something close to 76 Fahrenheit.